Hello, welcome to today's webcast series presentation, Erosion and Sediment Control on Linear Utility Projects. My name is Beth Brooks. I'm the Director of Civil and Structural Engineer Media. Thank you for joining this webcast, which is sponsored by SOX Erosion, Carolina Hydrologics, and Propex Geo Solutions. Before we begin today's broadcast, first some general information about the webcast and the GoToWebcast platform. The views of the speakers and organizations participating in this webcast are their own and do not necessarily reflect those of Civil and Structural Engineer or its publisher, SWAG Group. If you have any technical difficulties while viewing this webcast, please submit questions or a brief explanation of your technical problem using the Question tab on the GoToWebinar control panel, and a representative will assist you. During the webcast, you can also submit questions to our speaker using the same Question tab. Submit your questions at any time, and we will try to answer as many as we can later in the webcast. When you have a question for one of our sponsors, please begin your question by typing the name of the sponsor first, followed by your question. SWAG Group encourages group learning for our events. If you are viewing the live webcast with a group on one registered person's computer, that person must complete and submit the multiple viewer registration form for the group in order for everyone to earn credit. You can download the multiple viewer registration form from the Handouts tab on the control panel, and submission instructions are on the form. I'd now like to take a few minutes to introduce our sponsors for today's webinar event. We have SOX Erosion Solutions, Carolina Hydrologics, and Propex Geo Solutions. I've given them each the opportunity to briefly share with us a little more about their company and their service and product offerings.
Thank you for attending today's presentation. My name is Ryan Leeds, and I'm the Managing Partner of SOX Erosion Solutions. I'd like to thank Brooks of Civil and Structural Engineering, as well as Todd Sherrod from AECOM for giving us this opportunity. I'd like to briefly describe the systems and products that we developed and distribute here at SOX Erosion Solutions. As you can see, the premise of our system is stability, aesthetics, and improved water quality, providing a long-term solution to the problem of eroding hillsides and shorelines. 19 years old, operating in over 40 states and 3 countries. We design, develop, and distribute our systems in addition to training and certifying our ever-growing network of CSPs. Additionally, we work with engineers and contractors to develop solutions for their erosion control needs. The way the system works is unique in the sense that it is the only knitted and open system in the soft armored erosion control marketplace. We achieve stability by connecting to upland stable ground and transferring that stability to the newly established shoreline through our patented channel and anchoring systems. As you can see in the photos, the resulting stability that SOX provides gives root systems and vegetation the ability to establish and take hold. The advantage of our systems is the speed of deployment and the complete stability for thriving vegetation, as well as water filtration, reducing nutrient loading in the adjacent water bodies. Systems can be deployed in either a single layer yielding a specific grade or in a multi-tiered stacked array depending on the needs of the client. Our systems are filled with organic material, either dredged from the adjacent water body, hauled in from an outside source of earthen material, or blown in using a mulch or blowing compost truck. We manufacture our systems in 6, 12, and 18-foot sections, but the modularity gives us a lot of flexibility for in-field modification. It is said that a picture tells 1,000 words, and I can stare at these and listen to their message for hours. Municipal, private, public, federal government, FEMA, individual homeowners, golf courses, HOAs, oil and gas, and energy are just a few examples of the client channels that we provide solutions to. This series of photos shows the flexibility and durability of our system, going from a 4-1 grade to a shear wall to protect this large outflow culvert serving as the primary outflow for a 25-acre big box retail site in Augusta, Georgia. Mitigating sediment migration as well as improved water quality and mosquito control were the primary goals and achievements of this project. SOX Fence is an ultra-high performing silt and sediment barrier currently being used by municipalities in California to mitigate the risks related to mud and landslides. Unlike other silt fencing, SOX fence is non-trenched and has a 5-year warranty. All erosion control systems serve a purpose if they are properly spec'd, but as you can see on the right side of this slide, SOX is bioengineered, long-lasting, and meets all BMPs for living shoreline erosion control. Thank you so much for your time and attention and for caring about the stability of our environment.
Thank you so much, Ryan. Next up, we have Tim with Carolina Hydrologics.
Good afternoon, everyone. My name is Tim Marsack, and I am with Carolina Hydrologic. Carolina Hydrologic is the exclusive distributor of the Hydrolock family of polyacrylamide-based products. The products are used for sediment control and to clarify turbid stormwater runoff. Next slide, please. Some of you may be familiar with polyacrylamide, or PAM for short. PAM is a non-toxic soil binding agent. PAM is widely used in water and wastewater treatment today. The type of PAMs we use are called anionic, which is very important to know because there are many types of polyacrylamides out there. Next slide. As I mentioned at the start, our products are used to achieve two things, the first being sediment control and the second being water clarification. Our H30 granular line can be used in a variety of applications, including demucking sediment basins, under erosion control blankets or on wattles, for dust control, and especially as a superior tackifier. Our H30 liquid line also can be used for dust suppression and as a tackifier. The Flock product suite on the right there is a suite of semi-hydrated anionic PAM blended forms that are used to clarify turbid runoff. When the runoff flows over the product starts to dissolve and starts the flocculation process within the water column. Over a short period of time, the sediment will start to drop out of the water column, allowing you to discharge clean water from your site. There are two ways to treat the runoff with our products. The first way is to actively pump the water over the products, and the second is to passively treat the water by staging the products in the concentrated flow. Next slide, please. We always test soil and water samples with our products to ensure efficacy. This slide shows two tailgate tests we did on a job site recently this summer. The picture on the left is very, very silty soil, and the picture on the right is a very heavy colloidal clay soil test that we did, both with great results. That kind of wraps up my time. Next slide, please. If you have any questions, feel free to shoot me an email or go to our website to learn more. Thank you.
Thank you, Tim. And next up, we have Drew with Propex.
Yes, ma'am. My name is Drew Lawaza. I'm the Engineering Services Manager at Propex. If you're not familiar with Propex, we are a manufacturing company. We manufacture a lot of geosynthetic materials. This is a snapshot of our manufacturing plant in Ringgold, Georgia. We're an 800,000 square foot manufacturing space. We focus a lot on quality, on making sure that products are durable, withstanding the needs and the environments that they're placed in for each project. We've been manufacturing these materials, specifically our erosion control products, for over 30 years with over 40 million square yards of successfully installed products. We've been doing this a long time and have a lot of good experience, whether it's with the Army Corps or with other engineering firms, to work through the design process and the installation of these materials. Next, please. Most everything we do from the erosion control side is focused on the idea of reinforced vegetation. Vegetation itself is a great best management practice. It's a great way to control erosion and to improve water quality, but there's a hydraulic limitation of that vegetation by itself. And so we look to reinforce that vegetation with turf reinforcement mats or high performance turf reinforcement mats to increase the hydraulic performance of this system as a whole. This is something that we've worked with the EPA in the past on and established that these materials are best management practices in using vegetation in a higher capacity hydraulically, and also getting a large benefit from the environmental perspective as well. Next, please. We have a suite of products depending on the need. what we try to do is focus on the problem. What can we do to fix the solution in the most efficient, environmental, geotechnical, and economical way possible? So whether it's bank stabilization, slope stabilization, or erosion control within a channel, we have various options depending on the project need. We again try to focus it from a solutions approach, seeing what most efficient solution we can provide. Next, please. And as I mentioned, we are a manufacturer, but we very much so focus on the engineering support portion of this. I'm an engineer myself. We have a team of engineers in our engineering services department, as well as engineers in our market development out in the field as well. And what we try to do is, again, provide that service to understand what the problem is for the project, work with the engineer or contractor or owner to determine the best solution overall, whether it's partly Propex or partly other materials, a combined system. If you have any questions, we're here to support you guys, whether it's a geotechnical analysis, a hydraulic analysis, or just general support on installation. So thank you very much, and if you have any questions, you have our contact info there as well. Thank you.
Thank you, Drew. And as I aforementioned, you can also submit questions throughout the event and presentation to our specific sponsors by typing the sponsor name first and then your question, and we are going to be able to respond to all of those toward the end of the webinar. Moving on, a little bit about our speaker, Ted Sherrod. Ted Sherrod is a principal environmental engineer with AECOM in Raleigh, North Carolina, with key responsibilities involving management of construction, stormwater, and post-construction stormwater programs. Ted has worked in an engineering consulting role over the past decade, assisting clients, including the power industry, oil and gas industry, Indian nations, and numerous state DOTs on solutions for E&SC and post-construction stormwater challenges. He has worked on several projects with a major utility company for the past 5 years with an emphasis on E&SC design, permitting, and implementation. Ted holds bachelor's and master's degree in biological and agricultural engineering from North Carolina State University. He is a licensed professional engineer, civil in North Carolina, certified professional in erosion and sediment control, stormwater quality, and municipal stormwater management. Ted conducts seminars and training workshops in the erosion and sediment control and stormwater disciplines nationally and internationally. And at this time, I'm going to hand it over to Ted. Okay, Ted, it should be all yours.
Great, okay. Well, good afternoon, everyone. I'm Ted Sherrod, and we want to thank the sponsors today for presenting some information. I will specifically be reviewing some of the erosion and sediment control considerations for linear utility operations. I'd like to start with Ted's top 10 for you today when we talk about implementation. Stay out of those jurisdictional areas unless we're permitted to do so. How about turbidity curtains, where we have downstream water impoundments? Those are some additional components I'll touch on today in and around some of our linear utility jobs. Not only erosion and sediment control, but are we targeting those other construction site pollutants? How are we handling our concrete waste or other petroleum products on our job site and preserving water quality? Avoid these long runs of silt fence without designated outlets. Need those J hooks. See a lot of that on our linear projects. How can we address appropriate control there? Having adequate limits of disturbance, what I refer to as LOD, in our staging and stockpiling areas. So that's another key. We need sediment storage on our projects for these linear sites. Generally, we're so limited, but we need some type of traps or basins. I'll introduce some core fiber baffles to you today as another enhancements to help us on those job sites. Let's get that matting in correctly with anchor trenching, getting it stapled and installed correctly using our biodegradable products when we're adjacent to these environmentally sensitive areas or other kind of hydraulic erosion control products. And then, as one of the other speakers mentioned, using flocculants or polyacrylamides or PAMs, as I refer to today, to help address turbidity reduction. And one of the components we use on a lot of our linear operations involve horizontal directional drilling. We'll touch on some key plans that we need to review to address those inadvertent returns that we see sometimes. How do we calibrate our objectives on our linear projects? Here I've given you some examples of water quality target of 50 NTUs or nephelometric turbidity units down to 10. So our target is really trying to address very pristine water as it discharges from our job. I know this is a really great challenge, but I'd like to give you some tips today on how we can build margin into our plan to try to meet these water quality standards when we're working in and around these ESAs or environmentally sensitive areas. So what am I referring to as the ESA? Certainly any of the items that you see here listed on the right are surface waters, jurisdictional areas, riparian buffers, and many others that you could mention. So I'll really put a lot of emphasis today as we target protection in and around these locations. Can we designate an additional zone, additional footage? I've made a recommendation here to get an additional 50-foot margin on either side of our resource to provide additional protection at these locations. I'll use a lot of technology throughout, or terminology rather, through our discussion today. I'm focusing in on our construction stormwater management phase, which is that portion of the project where we're implementing our temporary and permanent controls. But I hear a lot of miscommunication from time to time as I move to different states. We really got kind of a compound term here when we discuss erosion and sediment controls. Our erosion controls are those that are addressing that detachment phase, our matting, our seeding, tarps, those type of things we're doing to address minimization of that detachment. Then we've got our sediment controls. Those are in place to address that transport phase, or once sediment has been detached, to provide protection where we may see the deposition or provide an area for it to deposit in. Those are our sediment controls. So I hear a lot of discussion with an erosion control plan. Indeed, that's your seeding plan, but generally we're talking about an erosion and sediment control comprehensive plan for our erosion and sediment control needs on our linear jobs. What are some of the concerns as you see on this particular site? Some jobs I've been on recently, contractors operated outside of the LOD, outside our limit of disturbance. Our perimeter measures have not been effective in and around these wetlands and stream areas. And although the plan may show measures, we just don't have the sufficient BMPs in place to control sediment on these long linear utility type operations. So what are some considerations we can look at the design phase or throughout the entire job? And I'd like to start with the kind of the design phase. If you're a designer that's tuning in today, we've got some non-structural BMPs we can include in our construction narrative, in our plan set that we can address. And I'm focusing now on the clearing and grubbing phase. How about limiting the contractor to only clearing areas and not grubbing until he's ready to pursue his grading or initiate his work on trench or whatever the case may be, if it's underground construction or above ground type construction, and having those BMPs implemented right after that clearing or concurrent with the clearing and grubbing operation. So is that included in your narrative? I hope so. How about other non-structural BMPs that we can include in our narratives at our temporary stream crossings, where we've got, indeed, these are permitted areas. We've got span bridges or culverted installations where we'll be crossing these locations like you see here in the photograph. And indeed, they're in place prior to our grading operations. All these sensitive areas require additional protection. How about other non-structural BMPs? Again, just narrative that we can include in our grading phase. Once grading begins, progress in a continuous manner until that section is completed and stabilized. Work in sections. So often I see our contractors open up too much erodible area that they cannot manage sufficiently. We see the potential for off-site sediment. So just don't like this starting and stopping and hopscotch around a job, but we can include in our contract language such that the contractor can address stages in his construction and complete the job section by section. And then again, the staged, I emphasize again, other non-structural components we can include in the narrative include staged seating as the contractor brings his cuts down or his fields up. Once he reaches maybe 10 foot in height on some of these field areas, he can go in and start stabilizing areas, or kind of use a trigger for exposure. If he's opened up an acre or more, be sure we've got some temporary cover in place. So a lot of these items can be added in our construction narrative that are considered non-structural. So again, we can emphasize our stabilization not only by stages, but our permanent revegetation, getting that in place immediately following our final grade on all of these highly erodible slopes on these linear jobs and the conveyances that we have. But we can also mention incorporating all of these components in phases throughout our projects. So not only addressing erosion control plan narrative components, we can really address these during our phasing to address how we're going to manage access roads. That's always a challenge on our sites for a linear job. We've got to access them from a location, in many cases, several hundred feet or lengthy distances. So we've got to have protection in and around these access roads. And from a designer standpoint, oftentimes I see us giving an inadequate area or footprint for a contractor to work in. So we need to provide adequate limits of disturbance so the contractor can access these areas. How about during that clearing and grubbing phase, have all of these environmentally sensitive areas flagged out, either highly visible flagging, fencing. I've seen different state jurisdictions require different components. Some use none, but if we're going to provide some additional protection, we need to be able to identify them. So again, many regulators consider once that tree canopy goes down a land disturbing operation, so we've got to have our measures in place. And many states require clearing and grubbing erosion and sediment control plans for linear operations just to address that initial clearing and grubbing phase. About once we implement our grading operations, once we get ready to open up those access areas or along the main line to initiate our trenching operations, or if we've got electrical utility structures that are going in place, we've got intermediate measures that we want to get in place. We can't just leave the perimeter measures there to provide all of our protection. And I'm emphasizing here a need to get those erodible areas stabilized quickly. Many cases, engineers will include a more aggressive time frame of 7 days instead of the EPA norm for 14 days for stabilization in and around these environmentally sensitive areas. And also, I've found that it helps our contractors to call out detailed narratives and details where we're doing dewatering in and around these environmentally sensitive areas, or if we have temporary culvert work. So call that out on your plans, include some narrative for the contractor to be able to address. And a common problem area, stockpile management. Have those stockpiles walked in, tracked in, knuckled in with the bucket such that we can get some temporary ground cover in place and have the perimeter protection there. We get into a lot of trouble where we don't manage our stockpiles in and around a project effectively. And a number of designers require intermediate erosion and sediment control plan sheets to address that intermediate phase on some of our projects. So as we go into the final grade of our jobs, once we're addressing our final stabilization, I've seen a need to address demo type narrative to address how the contractor will demobilize from a large sediment storage that we may be prepared, how that will be removed, how it will be returned, giving the contractor some direction on how to address that. And in some cases, post-construction structural measures will be included on some of our projects where maybe municipalities require the same. So once one of my big concerns is I see a lot of temporary BMPs remaining in place once we've already got that good 70 to 80% permanent vegetation. Your state may require a different value depending on your location in the U.S. But I like to see the temporary BMPs removed or indeed there for a temporary purpose for a limited time, and let our permanent BMPs, our permanent turf, serve as our primary vegetative component. So just some considerations for you. So just discussing that erosion and sediment control phasing tips. Many jurisdictions require a notification to the regulator, inviting them to the pre-construction conference. So often I see these cut and paste narrative info that's used by designers. So try to avoid that, where the same thing that you included on the last job is included on this job, but they all have their specific characteristics that you need to address. And do, as a designer, if you are in that role, anticipate the contractor's plan of action so you can include your narrative to address that component. And again, the narrative is so important, but many times I see it's just a checkbox that we've included. So let's address that in our implementation for our plan development. So how about once we start getting to the job site, we've got a number of these sensitive areas. I've noted a lot of them here across the top on the right, but our BMPs that are in these environmentally sensitive areas are generally non-excavated type BMPs. It's measures that we will minimize disturbance of the earth. So we have to limit our sediment storage, and sediment storage has to take place outside that environmentally sensitive area boundary. Perhaps we need a more robust design for our structural BMPs in and around and adjacent to these environmentally sensitive areas. So that's my point, kind of looking at wetland design tips. Again, installing these on perimeter areas, kind of surface related measures, no excavation, and provide some type of sediment storage outside that protected boundary so we can capture the sediment before it reaches the resource. And we know we've got to remove these. So again, any kind of stone that we have or riprap has to be completely removed from the jurisdictional area. How do you see one of the shots of an area that's really too much exposure with limited measures? Contractor got a little too far of himself where he had a span bridge, as you can see in the photo on the right. But again, another BMP that we use in and around our linear sites when we're trying to traverse over these environmentally sensitive areas. A number of jurisdictions require composite mats on job sites around utility structures, in and around wetland areas, stream crossings. So again, plan ahead, have those details available so they can minimize disturbance as they address treatment on these ESAs. Take a shot of this photo on the right. This is a photo from our research project showing some of the what I refer to as the normal Department of Transportation type standard measures, rock measures used on linear projects. What type of discharge do we see? And this was measured over 8,000 NTUs. You can see the one on the right, we're using some what we refer to as experimental BMPs, and you see a great improvement on the water quality. But when we add some type of flocculant, we're able to minimize what you see on the left from 8,000 down to sub 100 NTUs. So again, we've got a lot of technology at our availability that we can use on our projects. I know some states that may be listening have concerns. The regulators don't allow flocculants on job sites, but we've got a lot of opportunities where we're working in and around these high quality waters to provide a higher design standard, provide additional buffers. And that was my point. If we're dealing around these impaired waters, let's do over and beyond to provide that protection. So the way I look at it, once we get our design, we've got it in hand, we've got our project superintendents on the call today, our foreman on the call, our BMP installers here as well. Here are my way of looking at our implementation and maintenance type principles that we need to be concerned about. If we can divert clean water off these linear projects, we've minimized our risk. if we can, and what I mean by diverting clean water, in many cases we got pasture areas and ag fields routed right across that would drain on our areas. Let's turn that and divert that water away, slow down that dirty turbid water that we're capturing on our job site, like we see in the photo here, treat it with some type of BMP, impound it, slow it down, settle it, then release it and maintain it. So these are kind of Ted's tips on how our plan should be executed on the job site. I'm not a hay bale fan. Some of you may, some of my coworkers in Western US have indicated there are still hay bales used from time to time, but we've just got such superior measures in our toolbox now to use in lieu of hay bales. So let's get together as an industry and let's use some of these superior BMPs, and hay bales probably best used broken up, used as mulch, for example. Really one of the tools of our trade under linear utility operations or slope breakers or water bars, you may call them diversions, such that we can control that surface water runoff and direct it to an outlet. But in this particular case, you see it's not intended to direct it to a silt fence. We've really got an opportunity here for undermine or overtop, but outlet it to some type of sediment control measure that I'll give you some tips on here as we go through a little more. Don't track it like you see this one here that would promote acceleration of erosion. It should be tracked in the opposite direction. So my point about clean water diversions, I think all utility linear type jobs should utilize clean water diversions. You can see the example I've got here of intercepting that water coming from the shot on the left out of the wood line. Instead of running that across my linear run, I'm trapping it in a geotextile line ditch, routing it down to the stream, safely conveying it around so I don't have to deal with it on my job. And other options here shown on your right. But I give you a detail here, just gives an illustration. What would be excavated from that conveyance is bermed, seeded, stabilized, and then some type of geotextile or poly type material used as a liner to convey clean water, keep it clean, and send it to a suitable outlet. And I'll just give you some examples. Here's a screenshot from a linear job where we have a lot of adjacent run-on water, and I've kind of indicated here an example of where we could use a clean water diversion to keep that off of our grade and just route it to its location where it generally flows along the stream path here, keeping that clean water clean. Other types of measures I've seen to manage water on a job site. Now we're kind of working at managing construction site runoff, but I've used some wattle diversions. There's an example where I had a little access road adjacent to an existing stone line, ditch line. I was able to kind of use some J-hooks from a wattle standpoint and route a relatively steep area to a suitable outlet here, being sure that wattle was pinned down well. Metal stakes that we use are metal staples, as well as anchoring TP staking that you see here. But just an emphasis item, I've really been emphasizing the need for sediment containment on our linear jobs. I know we've got limited footprint, we've got minimal area to work in, but I'd like to ask you to look at what we can do to improve protection at these discharge points. We can't build a job with silt fence. That's kind of the point I was making here. There are additional protective measures that we need dealing in all of these long, lengthy slopes and steep slopes. Just create great challenges. So we've got to have a really suite of measures in our toolbox to address control. So just again, another screenshot I was looking at. I was asked to review these plans. We just had one sediment outlet location at this stream crossing, but we really had 4 discharge points at our stream on either side of all 4 points at the low point here. So we just got so much additional treatment we need to address at our environmentally sensitive areas. And we end up with this kind of scenario. You see in the foreground, this is a mat, timber mat is crossing at a stream location, but I'm right at the approach. and I'm trying to control the job with all silt fence, a little waddle here and there, and it just doesn't get it done. I'm asking for you to suggest another BMP, and we've got to have a way to slow it down and pound it, settle it before we release it, and this doesn't get it done. So how about some type of sediment storage, just a small trap, a small sump, a small basin to collect sediment. Example here, I'm showing along some of our access roads where we got the little small sumps in place to help us store that sediment on our job site. Have somewhere to discharge where we, at least if we're using our silt fence, have some type of silt fence break or silt fence outlet. Example that I'm using here is in a low point where it will discharge. We don't have an opportunity for a lot of stone on a lot of these linear jobs, which will select other products such as natural fiber wattles, for example. But these are some examples where we can provide some impoundment, settling, and treatment of the stormwater and allow it to be slowly released. Just a little detailed shot of the photo that I was showing. So again, if you don't have the opportunity to use aggregate, we've got the fiber rolls we can use. We can double stack these vertically at some of our outlets, at water bars, slope breakers, silt pits, turnouts, and provide a little sediment storage. But I also want to challenge you, if we are outletting our stormwater at these breaks and SFOs, silt fence outlets, we can provide some additional protection to minimize our risk of sediment loss with some of the core fiber baffles, and that's what I'm showing. I'm emphasizing sediment storage and baffles. So these are the core fiber products that are used to intercept that flow. Some other shots that you see used, they can work in small footprint areas. They really take the energy out of the water. They slow that flow, they trap the sediment, and they give you additional protection. So this is just another view of the steel post, the spacing, the type matting product, the wire supports that it rests on in another basin type application on a very large project. So core fiber baffles, in addition to our regular silt fence outlets with some type of sediment pit, trap, basin is critical. And so I'm introducing here opportunities at our slope breakers where we can come in. It's kind of the shot on your upper right, shows a scenario where we could mat our slope break, drop in a waddle to check the flow, maybe to introduce some polyacrylamide at that location, and allow a sump treatment before it outlets through a fiber roll, for example, at a location. So we provide treatment, we minimize velocity, we introduce flocculant, for example, we have sediment storage, and we have protection at the release point. I've got a lot of complaints on projects the last period of months, especially last year, about adjacent water resources, farm ponds adjacent to these linear projects. We know they just travel over the landscape through ag areas, industrial areas, commercial areas. But I've included some tips here on what we've done to add, as I mentioned in the shot previous, some polymer on water bars, adding additional storage at our outlet points, addressing Excelsior over some of our rock measures and adding flocculants, trying to get some immediate ground cover in place, addressing matting, and trying to obtain additional limit of disturbance area to get some sediment storage in place. And as you see at the bottom, we used this turbidity curtain where we knew we had some really high risk locations. And you can see the portion on the left after an extreme 2-inch thunderstorm, and we were able to provide some protection at this water body, at this pond. So just a screenshot kind of showing you a pond here in the upper shot. We've got one little silt fence outlet, looking for some more robust treatment to use at a location on a long linear project here to provide some protection for our downstream water bodies. So if we're dealing with a lot of colloidal clays, we can't depend on conventional BMPs. We need some additional technology. It's just my point. So wattles have served a good purpose, whether they're the core or the Excelsior materials, proper staking, proper treatment, proper installation, kind of showing in this shot just an installation where they're being stapled, they're being staked, and we're also introducing the flocculant to these, giving you a detail for that. In mountain terrain where it's hard to anchor a wattle, for example, still use a stone structural measure, wrap it with a matting material like you see in Excelsior here, and then apply flocculant on that location, get the same results of the earlier shot I was showing you where we could reduce our construction site runoff water quality values to much more beneficial levels. How do we address inadvertent returns from HDD operations to horizontal directional drilling? We know on linear applications, many cases we're under roads, under wetlands, under streams. We've got to have our perimeter protections in place around our bore pits, like we see here on the center, as well as managing around our solids management systems. We've just got to have good protection, good perimeter protection, and having a written inadvertent return plan for our HDD operations is critical. I've reviewed a number of those. They always address how a contractor will respond to provide containment where these drilling fluids may manifest themselves at locations we didn't anticipate, how the contractor will recover it, like he's got materials stockpiled on site in inventory so he can address containment, and then he's already got a recovery and a restoration plan of how he'll remove and or address stabilization and returning these sensitive areas back to their original condition. So I've talked a lot today about various erosion and or sediment control treatments we could utilize, but we know rapid vegetation establishment is so critical. I had a job that was open for multiple miles with limited temporary seating. They faced challenges the whole job. The next section of project that went on, they immediately implemented temporary ground cover. It helped them so much, and we know that's a component of our permit requirement is to get that early ground cover. So not only our early temporary, but just want to emphasize the importance of our final stabilization, whether we use a seeded mulch type operation or a rolled erosion control product, as we've shown here. In many cases, we know hydraulically applied erosion control products are also used on these linear utility type operations, as we see here, getting that hydraulically applied product in place. Our seed fertilizer limestone goes in, as well as a high quality material for serving as our final surface application. So we end up with the results here that we desire. So I've tried to just kind of pulling everything together for you today. Do you run up on projects like you see here on this photo? What type of supplemental BMPs that we've talked about today could we utilize for this particular location? We've talked about the potential for diverting clean water. We've talked about the potential for intercepting flows, storing storm water, treating it, and releasing it. So really enjoyed the discussion with you today. I'd like to conclude just by emphasizing the importance of following and implementing and updating your plan. Attention to detail, build it right the first time, manage the runoff. If you've got flocculants you can use, please consider that as well. Have some way to store the sediment on the job. Don't depend on a single measure. Clean water diversions, keep the clean water clean, limit the amount of exposure. Ask yourself, what is your buffer between your work zone and your water course? If you've got an adequate buffer in place, outstanding. Maintain those measures and get that veg in place. So hope I've offered some tips for you, and I'll turn it back over to Beth.
Thank you, Ted, so much. And before we get into the questions pertaining to the presentation you just presented on, I'm going to rewind it just a little bit, and we're going to go back and respond to some of the questions for our sponsors. I think I'm going to start with the SOX erosion questions we have here. Ron, are you ready for some responses to these?
Hey, Beth, yes, I am. I appreciate it.
Okay, here we go. Question number 1. What tools/equipment is needed to install the shore socks/dredge socks systems?
Yeah, that's a great question, Beth. Essentially, the tools required to install our systems are limited to simple items as simple as sledgehammers and shovels. Obviously, it depends on the environment that you're in and the substrate that you're working with. But our systems are designed to be deployed very quickly and very easily, and obviously connecting and transferring the stability from the upland environment down into the eroded environment is the key. So utilizing appropriate staking with our system, depending on the substrate that you are connecting to, would be utilizing things like field drills and sledgehammers. So very simple, very simple tools to use to deploy our systems. It's a good question, though. Thank you.
Okay. Next question. When you're estimating for the SOX systems, do you need to measure in linear feet or square feet?
So we manufacture the systems in linear feet, and we manufacture the systems in a way that it is a very modular deployment. So we manufacture in, say, 100-foot or 200-foot sections, and that is a linear manufacturing process. We don't recommend to our service providers, and we use the term certified service provider, which is our CSPs, which is essentially the network of contractors and installers that install our manufactured systems. We don't recommend that they quote in square footage, because depending on the resulting array or the resulting design of the hillside or shoreline that's eroded, we might pick up 6 feet, 6 square per 1 linear, and we could pick up as much as 12 to 18 square per 1 linear. So it just depends on the ultimate goals and needs of the client. But we generally instruct them to quote projects in linear footage, not square footage.
Perfect. Let's see. What makes SOX different from the other erosion control products?
How many hours do we have? Sorry. Look, as I mentioned in the presentation, I don't like to speak negatively about any erosion control product. I think that as long as EC products are spec'd appropriately, and the engineers and the contractors and the installers understand what the capacities are of erosion control products, and they're used and utilized and spec'd appropriately, then it's a smart idea. How we differ specifically is we are the only knitted system within the soft armored erosion control space. The nature of the way that our product is designed, if the system is penetrated or if the knit is undermined, it has a ripstop component to it. So generally, woven and non-woven products, if the structure of the weave is undermined, let's say by the dorsal fin of an armor cat or of a burrowing animal, then that entire system tends to unwind, right? So that's one of the issues of the woven product. Ours being a knitted product, if something were to undermine the knit, the actual system actually tightens itself. It's a series of knots. So we are knitted, not woven. Additionally, we are an open system, which gives us the flexibility to craft and mold and design in field as well as in the drafting room the finished product. So us being an open system rather than a closed tube, it gives us a lot of flexibility and malleability within the field.
Okay, thank you. We have time for one more briefly. This one says, can any do a SOX installation? I'm assuming it's meaning to say, can anyone do a SOX installation?
Can anyone do a SOX installation? Again, that's a pretty broad question, but I would say that any any contractor or any earthworks individual or anyone with field labor that can swing a hammer and tilt a shovel would be able to be trained to be certified in the deployment of our systems. As it relates to the SOX fence, I can tell you that my wife and daughter could easily deploy SOX fence because it is a non-trenched product, and it is a very lightweight system. We're using they're using the SOX fence system out in California for mudslide and landslide risk mitigation. And walking around on burnt out hillsides in California with heavy equipment is very, very difficult for contractors and firefighters. So our SOX fence system, which is a very, very high performing vertical sediment and silt containment system, only weighs about 16 pounds per 100 feet. So it's a very, very very lightweight and very durable and very long lasting. So depending on the product, I would say that they are easy to work with.
Okay. All right. Thank you, Ryan.
Thank you very much.
Yeah, absolutely. If you want to give them a means of communication with you real quick.
Absolutely.
Yeah.
Sure. You can email us at office@soxerosion.com, or you can give us a call at 561-501-0057, and you can also go to soxerosion.com, and that's SOX erosion.com.
Okay, thank you, Ryan. Next, Tim.
Yes.
Hello. All right, I've got a few questions for you. The first one is going to be, how do you use the PAM to demuck?
You use the H30 polyacrylamide granular product for demucking sediment basins. It's pretty simple. You get as much water out of the sediment basin as you can, and then you can use the powder to thicken the muck up at the bottom of that sediment basin, just using the bucket of your equipment, and there's rate applications and so on available. But as you mix it up with the bucket of your equipment, the muck really starts to thicken and turn into a peanut butter type of solution that you can get in the back of a dump truck, and you're not going to get a DOT ticket running down the freeway, losing a bunch of muddy water everywhere.
Okay. Do your products affect pH in the water?
No, the anionic polyacrylamide does not affect the pH. That's a very good question.
Okay. How does the H3O work as a tackifier?
So when you're using the granular H30 as a tack, it goes in with everything else into your hydroseeder, in your hydroseeder tank, and you make sure there's a lot of agitation. And the H30 actually binds with the soil particles when it hits, and that's allowing the water to infiltrate more, which in turn increases the germination rate of the seeds. Obviously, the best erosion control is vegetation.
Okay. Next one. Do the products biodegrade?
Yes, polyacrylamide does naturally degrade via sunlight.
Okay. All right, Tim, thank you so much. If you would like to give them your contact information real quick.
Sure. Anyone can shoot me an email at tim@carolinahydrologic.com or go to our website to learn more.
Okay. Thank you, Tim.
Thank you.
All right. Now we're going to move on to Drew with Propex. Drew, are you on the line?
Yes, ma'am.
Okay, Drew. First question. What are the environmental benefits of Propex's erosion control solutions?
So as we mentioned before, and as we've talked a lot, vegetation is a big benefit to the environment from the water quality perspective, and really the erosion perspective. It's the best erosion control. So the use of our materials allow for the use of vegetation in more severe hydraulic conditions. All of our materials are UV stabilized, so to not detrimentally affect the environment. They're not going to introduce any polyolefins or any microplastics into the environment that's going to have any detrimental effects. So you have a lot of benefit, mainly from the vegetation establishment perspective.
Right. Next question, what is their expected design life?
Different products have different design lives or functional longevities. All of our turf reinforcement mats are permanent with different levels of permanence. So anywhere from a 10-year to a 75-year design life. We do a lot of work for understanding and researching the durability of our products. All of our products are made from polypropylene, which is a chemically inert material that doesn't degrade except for exposure to sunlight or something that'll induce oxidation. And so with them being exposed materials, we have to do a lot to make sure that the durability is there for the life of the project, whether it's 20 years or 75 years. So we've done a lot of internal research, laboratory testing, as well as field performance for the past 20 plus years to really be able to provide a good comfort level with the design life on a lot of our materials up to, again, 75-year design life.
I'm sorry, I was on mute. Last question. Have they been tested, and how do they compare to traditional hard armoring solutions?
We've done a lot of testing for these materials hydraulically, a lot with whether it's TRI Environmental or CSU, Colorado State University. I've done a lot of testing for the Army Corps of Engineers for overtopping of levees and pretty extreme hydraulic events, anywhere up to 16 pounds per square foot of shear stress and 25 feet per second of velocity. We've done it in different states, so whether it's fully vegetated or unvegetated or somewhere in between. The erosion performance of all our systems, really every erosion control product with regards to turf reinforcement mats, the function of your soil, your vegetation, and your product. And so understanding those is important for us. So we try to take testing the knowledge we've learned and put that into a design procedure. We have a program called EC Design, which is available online, that allows you to sort of interpret between our laboratory tests and field tests to your actual project conditions.
Sounds good. Thank you. Thank you to all three sponsors today. At this time, we'll go ahead and move on to Ted. Ted, are you available?
Yes, I sure am.
Okay. All right, Ted. See, the first question that we have, how best we use these technologies to minimize sediments transport from catchment areas, recharging tributaries to drinking water, lakes, and reservoirs?
Wow, that is more of a kind of a watershed scale type question, but whatever we can do on our specific projects are going to have a impact certainly on catchments within larger sections of subwatersheds and watersheds. So my focus was just on a very limited project level, but certainly if we can address treatment on our particular site, we're certainly going to minimize that impact.
Okay. Ted, this is less of a question. You may be able to devise it into question form. Most power companies think they are exempt of these requirements in some areas.
Okay, at least in the states that I've worked in, primarily southeastern U.S., the power companies have taken a very proactive stance to managing erosion and sediment control on their sites. I've also interacted with a number of the power companies that attend our International Erosion Control Association conferences, and they have a robust program as well. So I know there may be scenarios in other portions of the U.S. where they may not have quite a robust program, but generally I'm seeing a very proactive, a very robust program for protection around southeastern U.S.
Okay. Congratulations, Ted, on your practical examples in presenting BMPs for erosion control. I understand that the examples are related to linear projects like bridges, roads, pipeline, etc. What are the applications for airport projects, as the runway may be considered as a linear one? Moreover, some building projects may involve large excavations, such as large real estate development projects. What is the applicability in this context? Best regards, Windsor.
Yeah, really, Beth, you can take any of the principles that I've addressed here from a linear standpoint and expand them out to whether it be vertical type construction, big commercial type development. We've got our and similar perimeter type controls, similar types of sediment storage, managing stormwater. So really this can be applied across the board. There is specificity when we deal with linear type applications, long, narrow strips of construction, but generally its components that we've talked about today are applicable to other grid-based or vertical type construction and airports.
Okay. Hi, Ted. Thanks for the excellent info. I'm in France and PAM isn't used at all in construction BMPs. Can you suggest a resource that would help inform regulators here that the product is safe?
Okay, yeah. In fact, I was talking with a guy in Spain recently that was having challenges with turbidity, and I think he was looking at using some of these products as well. So I can link up this question to maybe a person next door in Spain. But we've got research here from universities that show that the turbid water from our construction site is more toxic, if you will, than the stormwater is treated with the flocculants. So be glad to put this person in contact with the universities to see this published information. In fact, I also tested freshwater mussels here in the southeast that are very, very sensitive to sediments, and they used the flocculant polyacrylamide treatments, and there was no impact on these endangered freshwater mussels as long as they utilize that anionic using the correct product in the correct amounts. So be glad to link up this person with some university contacts.
Okay. Is PAM acceptable for all drainage streams containing fish?
Okay, first of all, PAM only is applied in and around the construction project. It's never applied directly into a water body, a stream, for example. The polyacrylamides that one of the sponsors mentioned, the ones that I'm mentioning today, are considered anionic. You can select and use, and regulators generally here only approve anionic polyacrylamides. They don't have the impact. They had all of the toxicity testing on the aquatic species, so they are allowed to be used. But just always remember, apply the polyacrylamide and have an opportunity for the sediment to settle before it reaches the stream. That's what place these type of safeguards in, just to place another level of protection while using them.
Okay, great. Ted, how do you address E&SC protection for laydown yards that support linear projects?
So yeah, many of these long linear projects have adjacent laydown yards that are really sizable, disturb a lot of acreage, and have potential for sediment export. So what I've seen, the erosion and sediment control designers always indicate a location on their plans for these laydown yards with the associated perimeter controls, sediment controls, and they're addressed as a part of the plan approval.
Great. And is E&SC included on your plans for all access roads?
Yeah, Beth, I mentioned, today Access roads are a really big challenge because most of these linear projects just are a narrow ribbon through the countryside, so they have to access them from some type of existing state road or secondary road. So in many cases, access roads are shown on the erosion sediment control plans and the associated measures and BMPs. In some cases, I've seen no erosion sediment control identified on the plans, and the contractor has to include and supplement. So there are always challenge areas of access roads leading to our linear projects. So be aware that's a target to review for improvement.
Great. Is the utility owner responsible for obtaining the SWPPP, or is it prepared and permitted by the utility contractor?
Beth, that kind of varies state to state. Many of the states that I've been involved with, the SWIP or erosion sediment control component of the SWIP is obtained by the utility owner. But I do know some states will task that to the contractor. Once the contract has been awarded to a contractor, that contractor will be required to develop and have the SWIP approved by the regulator. So it does vary.
Okay. All right. We have time for one more. How is E&SC training typically handled for project personnel?
That's pretty neat. You asked that question because on the jobs that I go on, I think that's another area we can target for improvement. A part of our SWIP requires training for the erosion and sediment control components that'll be incorporated on a job site. So I just remind all of the listeners today to to emphasize the need for erosion and sediment control training by the site personnel, whether it's a tailgate meeting or a meeting during a rainy day, that they can cover the installation maintenance needs. I've also seen them just set up a little demonstration outside the construction trailer and show them how to put in a wattle correctly or how to install a baffle correctly. So they can use these as opportunities to train their employees to really sharpen their erosion and sediment control skills.
That sounds great. Thank you so much. As we finish up, please download your certificate of completion now from the handout section. After downloading this certificate, enter your name into it and print and save a copy of the PDF. Note that the certificate will be available only during the remainder of this webcast. If you do have any issues in finding it, you may email me and I can send you a copy. My email address is bbrooks@zwaggroup.com. You can also find it on our website under the About Us page at csengineermag.com. If you missed our note at the beginning and you are watching the live webcast with a group on one person's computer, please download the multiple viewer registration form and complete and submit the form to receive credit. We need this information in case you are audited and we are contacted to verify this continuing education activity. Additionally, this webcast has been recorded and it will be archived on csengineermag.com/continuing-education. A PDF will be available with written answers to all of the questions submitted during today's webcast. Please visit csengineermag.com/continuing-education in 2 to 3 business days to view or download the complete Q&A for this webcast. I want to thank Ted and all of our sponsors and all of you who joined us today. And this ends today's webcast.